Hello, in this video we're going to look at a useful trig integral, and this is used if you use the CDF technique to find the density of a non-central chi-square, and I will give hints upon how it's used in the example on page 2. So here the integral that we want to evaluate is the sine of x raised to the nth power, and we're going to use integration by parts to do it. So we're going to split this to sine of x n minus 1 times sine of x. So this is the same as that. We're going to let u be this piece here, the sine of x raised to n minus 1, and dv be sine of x dx. And then the derivative, and then the anti-derivative. And then this is uv evaluated from 0 to pi, and then that minus comes out and makes that a plus, and then this is v du. When we evaluate sine at 0 and pi, we get 0, so this left piece goes to 0, and then we bring this down. But instead of cosine squared, we use 1 minus sine squared. Now we multiply this into both of those to create two integrals, which is this. Now, this piece here is actually the same as this piece. So when we add this to the other side, we get n of these, is equal to this. Now we divide both sides by n, and then we get this formula. So what we've done is taken it to a power of n to a power of n minus 1. It's a power reduction identity. And then we can keep repeating this until we get to where this exponent is a 1 or a 0, and then we can evaluate it and then back populate and find the original integral. And something happens very similar to the cosine, and we won't go through as many details, but you also, to evaluate this, use integration by parts. So we split it, and then we let u be this piece and dv be this piece. Take the derivative, take the antiderivative, and then this is uv, and again when we evaluate sine at these, this is 0, goes away. This piece is v du, but notice that negative sign comes here and changes it to a positive. So then we take this and bring it down, and instead of making this sine squared, sine x squared, I just went ahead and 1 minus cosine x. Multiply this into both, we get two integrals. And then this piece is just like the original, so we add it to the other side, and then there's a n times that, and we divide by n, and we get this. So this is the original integral is equal to this piece. Now, one approach, I'll illustrate this in a second. So when n is 1, then we can just evaluate this. The antiderivative is cosine, minus cosine, evaluated from 0 to pi. That's 1, but the minus, and we get 2. Now this can be rewritten in this form: 0 factorial pi to the 1/2 over gamma of 3 over 2. And you'll see why this becomes important in a second. Here, and so instead of 1, we'll just go to a 2. And then the power reduction formula says it's 1 over 2 sine of x to the 0, which is 1. So then this piece is just pi, of course, then it's over 2. And this can be written in this form. Now, sine of 3, sine of x to the 3rd power is equal to 2 over 3, n minus 1 over n, and then it's raised to the 1st power, minus 2 of that. But this we just evaluated at 2. So this piece is 2 times that, which is 4/3. And then you can write it in this form here. And then very similarly, if we have it to the 4th power, then it's this, to the 3 over 4. But sine of x squared, this integral we just evaluated, which is pi over 2. So it becomes 3 pi over 8, and it can be written in this form. And then to save time, each one of these integrals can be done in a very similar fashion using the results from the previous one. All right? And it can all be written in this form here, where it's factorial and a pi to the 1/2 and a gamma function. Now, depending upon if n is odd or even, if it's odd, then the gamma's in the denominator and the factorial's in the numerator. If it's even, it's the other way around. But notice that to evaluate this, then we have to, well, no, this is it. Okay, so then when this integral here, and so there are n integrals, each of them evaluated 0 to pi, and there are n variables here. So notice that this first one, so we evaluate this integral, right, and the rest do not have n x to the nth. That is going to be this. Okay, so then that can come out front, and then we evaluate the next one, which is sine of x, to the n minus 1 raised to the second power, which is going to be this. But notice, and then that goes out front, but notice that the pi or gamma of 3 over 2 cancels with this. And then this is raised, pi to the 1/2 squared, right? And we still have the 1 out front. And then when we evaluate the third integral, that's raised to the third power, we get this, and then that goes out front. But notice that the 1 factorials cancel, and then we have pi to the 1/2 to the third power, and of course that we carry that along. But each successive step we get cancelizations, and so this ends up being a very simple formula. I'm going to leave that as homework because we'll probably use this when we derive the density of a non-central chi-squared, but I'll leave that as homework. And just as a quick reminder, this is needed in the development of a non-central chi-square distribution. I guess when you use what's called the CDF technique, you find the cumulative distribution function, and then you take the derivative, and then you end up with the density. But this is used. Well, I hope you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.